Over the centuries, we've come to understand that the Earth spins steadily on its axis and has been since the beginning of creation. This rotation contributes to so many factors which include weather patterns, gravity, speed, oxygen levels, and even down to the migration patterns of animals. But it turns out this rotation won't last forever. So the real question is, what would happen if the Earth stopped spinning? Well, join us as we reveal how something terrible is happening to Earth's rotation and no one knows why. Ever since Earth was created, about 4.5 billion years ago, our planet has been on a continuous rotation, spinning on its axis. Much like how other celestial bodies form, Earth was formed by the gradual accretion of rock and dust floating in space which clumped together, resulting in this spinning rock we call home. But this rotation, however unnoticeable, has been gradually slowing down over billions of years. The length of day and night. Today, it's an established fact that a day consists of 24 hours, but our study of Earth's rotation let us know that a day was not always as long. Over the course of billions of years, Earth's rotation has gradually slowed due to several forces both on and beyond Earth's surface, resulting in much longer days over time. This gradual reduction in Earth's rotation adds about 2.3 milliseconds to the length of each day every century. A little over 2 billion years ago, Earth completed a full axial rotation in just under 18 hours, meaning we only had about 9 hours of daytime and the corresponding number of hours of night. But although Earth's rotation is gradually slowing down for the most part, several factors have actually worked to speed it up for short periods. For instance, the end of the last ice age resulted in a massive amount of polar ice sheets melting, which caused a significant reduction in surface pressure. This process caused the Earth's mantle to slowly begin moving towards its pole, and therefore causing the planet to spin that much faster. Take a ballet dancer, for example. As they begin to spin, pulling their arms towards their body, they increase in speed, and this is similar to the process of the Earth's mantle moving closer to the planet's axis. Although this only happened for short periods, usually a few thousand years, the process adds about 0.6 milliseconds to the length of a day each century. This just goes to show that so many processes contribute to how fast or how slow the Earth rotates. Also, the connection between the Earth's surface and interior mantle has significant effects on the rotational speed of the Earth. Seismic activity such as major earthquakes has been recorded to either speed up or slow down the rotation of the Earth. For instance, the Great Earthquake, which had a magnitude of 8.9 and erupted in Japan in 2011, has been revealed to have sped up Earth's rotation by a minuscule 1.8 milliseconds. The devastating earthquake that hit Indonesia and other countries along the Indian Ocean in 2004 caused a slight shift in continental plates. This particular event sped up Earth's rotation by some 3 milliseconds. Scientists have been able to invent instruments that measure even the slightest change in our planet's rotation using a brilliant technique known as very long baseline interferometry. This method relies heavily on the use of telescopes located at different points on the Earth's surface, all of which are assigned to specific signals from outer space. As the Earth gradually spins, these telescopes record the amount of time it takes for each signal to appear and disappear. Using this data, scientists can measure with extreme precision how fast or slow our planet rotates, and can determine if each day is longer or shorter than the one before. But although seismic activity and certain weather phenomena contribute to the acceleration or de-acceleration of our planet's rotation, the major determining factor to the speed of the Earth is in fact the Moon. The Moon's impact. Much like the Earth, the Moon has been in existence for over 4.5 billion years and has had a push and pull relationship with Earth for almost as long. For billions of years, the Moon has been the major factor causing a gravitational pull on Earth and gradually, but surely, slowing down its rotation. The gravitational pull from the Moon is the reason why days were much shorter billions of years ago, and it will also be the major reason why days will not only be shorter millions of years from now, but the planet could completely stop in its tracks. This continuous mechanism results from the exchange of gravitational energy between the Moon and the Earth. Being a celestial body on its own, the Moon exerts a gravitational gravitational pull on Earth, which results in a slight but significant bump on the surface of our planet. This pulling force creates some kind of torque on both the Moon and the Earth. The resulting effect on the Moon is that it is gradually pulling away from the Earth, while the effect on the Earth is that its rotational speed gradually reduces. Today, the gradual reduction in Earth's rotation results in a 1.8 millisecond increase in the length of the day, while the effect on the Moon causes it to move 1.5 inches away from the Earth each year. This process has been going on for billions of years, and researchers have stated that a little over 1 billion years ago, a day was just 18.7 hours, and the Moon was 27,000 miles closer to the Earth than it is today. This effect isn't noticeable in our day-to-day lives, and scientists have reassured us that the gradual spinning process will continuously happen for the next millions of years. Since scientists have assured us that there's no imminent danger to our planet's rotation stopping abruptly, it leaves one pretty curious question. What would happen when our planet eventually stops spinning? Effects on the weather. Despite what most people might think when our planet does eventually stop spinning, we won't all be flung into space from sheer force. One of the most noticeable changes that will occur is that with no centrifugal force acting on our planet's surface, the oceans and seas would cease to flow radically. These bodies of water will be pulled to the points with the strongest gravitational force, which happens to be the North and the South Poles. This would result in unimaginable levels of continental flooding and also cause underwater continents to arise around the equator, bounded on the south and north side by sea. Also, atmospheric patterns will be drastically affected. Once the planet stops spinning, there would be a sharp drop in wind speed, which has a significant effect on weather patterns, such as rainfall, distribution of air temperature, precipitation, and even the capability of the ozone layer. Another scary aspect is that a motionless planet would most likely live on a planet with no active magnetic field. Scientists are still unsure of how the rotation of the planets affects the magnetic field, but if we are to lose them, it will leave the surface of a planet vulnerable to harmful radiation from the sun, cosmic rays, and other interstellar radiation and winds. Effects on day and night. Another noticeable effect that would happen is that night and day cycles would cease, as there is no rotation for the sun to rise and set as usual. Instead, there will be a permanent day on one side of the planet and a permanent night on the other. This would be incredibly devastating, as the dark side of Earth would find itself in perpetual cold and darkness. With no sunlight for plants to photosynthesize, all plant life will die out in a matter of weeks, leading to extreme famine that would wipe out billions. This night side will also find itself in the harshest and longest ice age the Earth has ever experienced. Things on the sunny side of the planet would not be peachy either, as the scorching heat from the sun would be rained down on that half of the planet. There will be extremely high temperatures, which will result in extreme droughts. Desertification will cover previously tropical areas, and most continents will become barren wastelands. Effects on animal life. Before extreme heat and cold will take out much of the plant life around the world, animals will also be affected in one of the worst ways possible. All animal life on the planet is used to having a 24-hour day and night with them, which is known as a circadian rhythm. This will hinder important life and metabolic processes in all animals, as it signals our body when to sleep and when to wake up, depending in part on the changes in sunlight and night. The life cycle of most animals and insects will be thrown into complete chaos. Most animals that use the fluctuations between day and night for migration and carrying out daily functions would lose all sense of functionality and direction. This would result in massive disruption and possibly the extinction of animal life all across the globe. But the truth still remains. Our planet will continue to spin with no noticeable differences for the next millions of years. But that's our own scientific opinion. What do you think?